I will run by the order of the presentations from the first team to the seventh team of the school first, and then university. I want to make sure that everyone are here in the live Zoom room, and then we will go live in about 10 minutes. So that's event start. Okay. The first team, low smoke charcoal. Are you here?
Yes.
Yes. Okay. Nice to meet you. Acrosense.
Yes.
Yes. Okay. Nano air filter.
Yes.
Okay. Bedding material from corn stem.
Yes, I'm here.
Okay. Aloe vera chitosan. Hello. The team from Vietnam. Aloe vera chitosan. Are you here? Wait a minute. ทิ้งไว้หรือเปล่าครับมันก็เลยไม่กลับโอเคไม่เป็นไร green gel.
Yes, I'm here.
Okay. Green circuit. Green circuit.
Yes, I'm here.
Yes. Okay. This is the order. Like, we start from low smoke, charcoal, acrosense, nano air filter, bedding materials, aloe vera, green gel, and green circuit. Before we start from each team, we have the MC. She will tell that you need to introduce yourself a little bit, and then we will play your video. It will take about 3 minutes, 2 to 3 minutes, and then there will be Q&A sessions from us, the panel. Okay. And the morning sessions will end around 11:30 to 11:40, and we take a break about 15 minutes, and then we come back 12:30 again for the university, which are the first team to present is CSP application. Are you here? CSP application. Okay. Mango skin. Mango skin. No, not yet. Vertical farming for duck. No, not yet.
Yes.
Oh yes, no, yes.
Yes.
Nice to meet you. You from UGM, right?
Vertical farming is from UPI, Indonesia.
Oh, okay. No, different one. Okay. We have many teams from Indonesia, so I might missed something. Okay. Edible cement from food waste.
Yes, I'm here.
Okay. Ecofoam. Ecofoam. Okay, not yet. VR bone.
Yes, we're here.
Yes. Good morning. And Azoila cap.
Yes.
Okay. Azoila cap. Okay. That's great. The same. Okay. Before you start, the MC will tell you to introduce yourself a little bit.
Recording in progress.
Okay. And then we'll continue with your video and then Q&A. But your session will be in the afternoon. Okay. And after the university session, there will be some talk, a little bit, very short, and then the announcements for the awards. So please stay tuned for us the whole event, and I hope you also have fun. Yesterday was a fun event and very knowledgeable. So you can learn from the others. All these questions were not predetermined. It is exactly to your project, right? So you don't expect the same questions all the time. It doesn't mean that you hear your the group before and then you expect the same one. Okay. So I believe that there's still a time a little bit, right? Yeah. So we wait for the others. By the way, Acrosense Are you Acrosense?
Yes.
Are you here? Yes.
Yeah, we're here.
Okay. We replaced your new video right now. I hope
Okay.
it is right, candidate.
Thank you.
And mango skin. Okay. Again. Mango skin. Okay. No. Okay. No. No worry. They would. I believe they will come anytime soon. Okay. So งั้นเดี๋ยวเปิดวิดีโอเล่นไปก่อนแล้วเดี๋ยว Yeah, so we'll have a little break and then we'll come back again near 10. Okay. I hope everyone will prepare for the competition. Okay. See you again.
Ladies and gentlemen, distinguished guests, and brilliant students, welcome to the second day of KU BCG Ideation Challenge 2023 on final round competition for non-food category. This event is our initial online competition that gives high school students and university students an opportunity to share interesting ideas on how to solve global issues, both food and non-food category. Once again, we congratulate to all the winners and first runner-ups from yesterday competition. It was such an amazing event and incredible ideas we have witnessed. Today, 17 from school level and 17 from university level were selected. After the opening ceremony, we will start off with a school level session at 10:15, followed by a university level after a lunch break at 12:30. Let's enhance this event by having everyone open the cameras and turn off your microphone when it's not your presentation turn. First of all, please allow me to introduce myself. My name is Methawi Sankong, a Foreign Relations Officer of Kasetsart University. I am going to be an MC for today's event. Now, let's take a moment to acknowledge the judges who will be carefully evaluating the ideas today. First, Associate Professor Dr. Apishat Rojanarowan, Assistant to the President for Quality Development. Second, Associate Professor Dr. Anchasa Pramon Charenkit, Kasetsart University International College. Third, Assistant Professor Dr. Arashak Prasain, Department of Architecture, Faculty of Architecture. Fourth, Dr. Rangsima Cholakup from Biomass and Bioenergy Technology Division, Kasetsart Agricultural and Agro-Industrial Product Improvement Institute. And fifth, Professor Matthew P. Downs, Consultant for International Education, Faculty of Economics, Center for International Affairs. Next, as we dive into the heart of this competition, it's crucial for everyone to understand the criteria that will guide our judges in their evaluations. Remember, the criteria include 6 aspects. 1. Creativity. 2. BCG concept. 3. Impact. 4. Possibility. 5. Presentation. And 6. Question and answer. Before we proceed, I would like to extend a respectful invitation to Associate Professor Dr. Chamay Park Michael, Assistant to the President for International Affairs, to make the opening remarks.
Thank you very much. And good morning, all the judges, contestant students, advisors, ladies and gentlemen. On behalf of Kasetsart University, it's my pleasure to warmly welcome all of you to the second day of the final round of the KU BCG Ideation Challenge. This is our first ever ideation competition hosted online by our university. And we have continued mission and commitment in sustainable innovation, which have generated long-term social and environmental benefits. And these are in line with our country current bio-circular green economy concepts. This BCG concept means we use science, technology, and innovation to transform our biological resources and cultural diversity into economic value. as you may have learned from our website and other resources. And I would like to take a moment to congratulate all the 14 finalists today from both school and university level in non-food category. It is an honor for us that a good number of students from several ASEAN +3 countries, specifically Cambodia, Indonesia, Laos, Vietnam, and Japan, have joined this first competition and have passed to the final round yesterday and today. And we believe that an event like this one is a great opportunity to enhance your creativity and other higher level thinking and learning skills. So this is a special occasion for all of us to learn from each other and also from the expert judges. So I would like to express my sincere appreciation to Dr. Arachat Kasain for initiating and implementing this project from beginning to end. Also to the other judges for their very kind and prompt acceptance to take part in our event. I would also like to acknowledge the hard work of the organizing committee from the International Affairs Division at Kasetsart University. And thank you for having been working hard in the past few months to make this event happen. And I would also like to thank all the students and their advisor for being interested in this competition and for submitting your ideation proposals to us. So finally, without any further ado, I would like to declare this event open, and I wish all the contestants success in the competition and a fruitful time. Thank you.
Thank you, Associate Professor Dr. ชมัยภาคไหมกะ So let the competition begin. The following represents the sequence of teams for today's order. 1. A low smoke charcoal incense from Cedar Peel from Thailand. 2. Agrosense from Thailand. 3. The development of nanometer scale air filters using a manufacturing process involving fibers from sugarcane bagasse and coated with lignin from Thailand. 4. Bedding material for animals from modified corn stems from Thailand. 5. Formulation of nano-curcumin gel combined with aloe vera essential oil and cortisone for treatment of vaginitis in females from Vietnam. 6. Green gel from Thailand. And 7. Green Circuit Tiger Ranger from Thailand. May the first team, Low Smoke Charcoal, please briefly introduce yourself before we open your video.
Excuse me, there one team missing from our recording, so please check the email again if that's possible. Thank you.
Okay, while we are checking for you, please the first team, briefly introduce yourself before we open your video.
Hello. My name is Parame Subhapanukul.
My name is Shanashida Sumaitirapat. My name is Kanitha Dechalitwong. So we are from Princess Julapon Science High School, Pathum Thani, Thailand, and we are the team of Low Smoke Incense Charcoal from Sitat Hill. Yeah.
Thank you. Please wait for a moment while we are opening your video.
To the committee and the audience, we are delighted here today to tell you about our idea. First, smoke charcoal incense from Cedar. This idea originated our experience of inhaling smoke from incense at a temple leading to eye irritation and respiratory discomfort. Recognizing health hazards associated with incense smoke, particularly its role in causing lung cancer and respiratory disease, decided to add this issue given a prevalent use of incense in temples. After studying the smoke, which contains carcinogens such as benzene, phthalate, and benzoyl, as well as hazardous like sulfur dioxide, nitrogen dioxide, and carbon dioxide. For an alternative solution, powdered citrus could serve as a viable substitute, also addressing the issue associated with citrus. To utilize citrus peel effectively, as the blend peels catch fire more easily than regular dry peels. The blend peels are then ground into powder. Mixture of rice flour with a higher amalgamated content, and regular rice flour is used as a binder. This combination facilitates easy molding and reduces smoke during combustion. This information refers to specialists in the technology research and development division.
Implementing these innovations can have several positive. First, environmental, reduce air pollution from incense smoke. Second, health, lower risk of lung cancers and respiratory disease for users. Third, waste reductions, decrease waste from unused orange peel. Fourth, economics, creations of income opportunities for merchant selling unused orange peels. Further developments can focus on reform to minimize smoke and optimizing the ratio of ingredients for the least amount of smoke generations. In terms of business, establishing a brand identity and initiating promotions such as distributing samples in various locations has encouraged adoptions.
In summary, this innovation not only addresses health and environmental concerns, but also contribute to waste reduction and potential economic benefit for local business. So thank you for attention.
Thank you.
If the judges have any questions, address your inquiries during this session, please.
Yeah, I have to pick it up. Hi, I'm Professor Matt. I have a question. I just curious in terms of the culture. I thought that smoke was an important part of the religious ceremony. So if you get rid of smoke, are you hurting the one aspect of the religious ceremony?
Can you repeat the question again?
Okay. Yeah, my understanding is that smoke is actually an important part of the religious ceremony. That the smoke is important in terms of helping the blessing go up to heaven, and reaching the spirits, etc. So I'm just curious if your idea really hurts the whole purpose of the religious ceremony. Can you hear me okay?
Okay.
Okay. Due to the circular significance of using incense sticks, which has been a part of Thai culture for a long time, we want to address the issues of pollution from incense sticks without affecting benefits.
Okay, so I'll ask you as well. So basically you choose the orange peels, right? And the lemon peels, right? And what is why you come with this raw materials? Why don't you choose something else? Why these two are so important for you to choose?
Because like sitaat peel is, we don't like to use the peel of sitaat to eat or something. It will be waste, and it's easy to find in Thailand. So we should use to like choose this peel.
So have you tried to think about you think it will be marketable? For example, you think the cost of production it's more or less, or it's okay to be able to marketable later on? You think it's what is the potential of 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 selling this product?
I think the cost is maybe the same like normal incense. Yeah, and it's easy to buy and easy to use it.
Hello. Yes. That's a technical question. So you said that you can explain why is non-smoke. Can you explain the mechanical of this citrus peel? Why they give non-smoke for this incense is compared with a different with a normal incense?
So the normal incense in like market in Thai or another country, it will have something like uh much smoke and have like lead to disease or something. So our idea, a low smoke charcoal incense from Sitat Pure will have a low smoke and don't have like smell or cause that lead to disease. Yeah.
Yeah, I never thought about it. I mean, did you do a study or did you do research that the smoke and the smell from the temple really is a problem? I mean, is this a problem? I didn't know. So I'm just curious. Did you do research to find that this is a health problem?
Okay, so we have to research about that cancer. It will be from like a smoke from the incense or something like when we have a temple, we use in a community, something like near the community or near this location that have more people. So we think that smoke from the temple will be annoying or make a disease, something like cancer or respiratory. Yeah. So we think it will better if the incense didn't have smoke or have the cause to lead to disease. Yeah.
May I ask the question? Can you hear me clearly?
Yeah.
Okay. So actually, for an example, I think you know what Leng Yi, the Mangon temple, right? They
Yeah.
stopped using the incense already. So what will you develop your, product? Uh, when they stop using the incense everywhere, what do you think you will develop your product for further, or you will stop doing this product? Can you give me some idea?
Can adjust to the method to
Burning. So something like maybe develop to have a smell better, like therapy, like aroma or something.
Aromatherapy.
Yeah, and maybe we have to like start research process to adjust the formula to be suitable for the food peel or type of flour, modify according like to the community. So it will have like income distribution to the community. Yeah.
Thank you so
Thank
much,
you.
Low Smoke Chateau. Now it's time for the next team. Acrosense, please briefly introduce yourself before we open your video.
Hello, we're from First Time School and we'll be presenting our work, Aggressons ML.
Thank you. Please wait for a moment.
We will be presenting our idea, Aggressons ML.
เหล่านี้อยู่ที่อำเภอโนนไทยจังหวัดนครราชสีมาจะเห็นได้ชัดเจนว่าพื้นดินเป็นนาเกลือซึ่งยากแก่การเพาะปลูกและชาวบ้านยังประสบปัญหาภัยแล้งซ้ำซากทุกปี
Roughly 20% of the total farm area faces damage, resulting in substantial financial losses for farmers. The estimated loss is 3,394,966,021 baht. This problem has the urgent need for innovative solutions. Rice has long been Thailand's most important crop and its major agricultural export. Rice cultivation thus accounts for 46.1% of all Thai farmland, which highly affects the economy. Prices for Thai rice have risen sharply over the past 2 years. The total area of rice under cultivation fell under the impact of drought and lack of access in irrigational water, then restricted supply, while baht has also been appreciated in value in recent years. These two factors then combine to erode the price of competitiveness of Thailand rice industry relative to the country's major competitors. So how can our AgriSense ML resolve this issue? So our first part of the system will be the forecasting system, which is the farmer drought severity index and moisture index to forecast when for the farmers not to plant and when to plant. And the forecast will send signal through our application. After forecasting, our machine will run along the track, and the input from the forecast will let the machine know what season this is for the machine to calculate the inputs. Soil moisture management. Addressing soil moisture irregularities, the machine calculates the precise amount of water required, whether the soil is too dry or too moist. pH level correction. For the pH imbalances, the system recommends corrective measures. In acidic soil, acidifying fertilizers containing elemental sulfur, the machine calculates the required grams for each area based on the machine learning database. Comprehensive monitoring and alerts. The system continuous monitoring is complemented by real-time alerts. If unusual variation persists, the machine signals the app. Since our goal is to expand our project all over Thailand, which we will develop the forecast system in each city, which our potential will be measuring with sensor. Once we measure, we will collect the database into our cloud and collect it as our main data. There will be part that will show the visualization and let people analyze and forecast in the future when to grow and when not to grow. The integration potential of AgriSense ML with the IoT devices, sensors, and other smart agricultural technologies open up avenues for enhanced capabilities and broader applications in modern farming practices.
BCG Confirmation, our machine focusing on precision resource optimization aligns with a circular and sustainable economy in agriculture. By minimizing waste, reducing chemical inputs, and promoting efficient resource use, it fosters a more sustainable and resilient agricultural system.
The judges may address their inquiries now.
Okay, go ahead.
Yes, your creative is very great because the principle is great that you can measure the pH, the soil. But I want to know the principle of the machine that to test and how long for your test and you can and how long for you evaluate all the data together and you send this from the machine to application.
So for our sandbox, we'll be using around 1 year to test all the seasons, and then we collect the data. However, from the data to the cloud to show the visualization, it will only take 2 or 3 days to generate the information into the application.
I just want to dig down a little bit in details. For example, if you have this sense, right? So can you just briefly introduce to me how you're gonna conduct the test?
The test for the seasons, right?
Yeah, the pH, the moisture, whatever. How you gonna do it? For example, you're gonna poke that in the soil. How deep? You know what level? You know those kind of things. Just give me a little bit more. What your thoughts on this?
Also for the pH, we're using the normal pH meter. And for the moist, we're using the sensor. Yeah. But can I add a bit more to that? So for the water, we're using HAPS Unit 1, which we will fertilize water from the dirty water sources as well. So we will reuse the water, not from like rainwater or anything. We will reuse the water from like rivers so that we can recycle it. And then once we filter it out, it will be in our machine and we can use that water.
Who's going to do the test? Does a farmer, you train a farmer to do the test? Is it a simple machine that each farmer can do it? And here's the other part of the question. So who's going to do it? But also, is it crop specific or is it region? In other words, you take the testing for one big region or one province, or do you do it for each farmer in each field so you know the difference between this field, that crop, this crop, that crop? So who does the test and how specific?
So for the test, we will be the one who started first for the database collecting. And for each province, there will of course be different PSDI and MI level. So we're still using Nakhon Ratchasima as our sandbox first. So we'll be the one who do it. And for the water recycling, the HAPS will be like a machine. So farmers will just be the one who collect the water, just that. No technical work.
Okay, so we're a little confused. Are you creating the machine or are you creating an application? What is your creation specifically? We're a little confused. Are you creating a machine? You're creating an application? You're creating a mathematical calculation? What is it you're creating?
Both the machine and the application.
Okay. What do you project as the cost of the machine?
Yeah. Around 20K. Because we're using machine learning and we need to create the track as well.
Okay, I think that's enough.
Oh, really?
Yes. On slide. So just one more question. Okay. One question. Yeah. No,
I want to add the questions like if it is possible, you know, your machine really possible and with this cost, okay, and how it can be like a profit to everyone, like, you know, not just not just only the one that you present. Is it able to be like, you know, profit to or benefit to others? Do you have any idea?
Oh, we're planning to get the revenue from the CSR.
No, I mean people that can get the benefit, not monetary benefit, but it means you have the benefit of better quality of life from your invention.
I think farmers will get benefits because we're predicting the seasons for them, when to plant and not to plant, so they will not use their products and waste their fertilizers and stuff.
Okay, thank you very much. ขอบคุณครับ
Thank you very much, AgroSense. May the next team please briefly introduce yourself before we open your video.
Hello and good morning, everyone. We are from Princess High School, Pathum Thani. Our group solved the problem of sugarcane bagasse waste. Hope you enjoy our presentation. Thank you.
Thank you. Please wait for a moment.
Welcome to our presentation, the development of nanometer scale air filters using a manufacturing process involving fibers from sugarcane bagasse and coated with lignin.
And this is the beginning of our project. We want to solve the problem of sugarcane bagasse waste and the efficiency reduction of air filters. Therefore, we eliminate this waste by turning them into air filter sheets made of nanometer-sized sugarcane bagasse fibers and coated with lignin.
Why nanometer size? The answer is to enhance air filtration efficiency and to be used with the third layer of the air filter, which can increase more efficiency compared to general air filters, which most of them can filter air at the micrometer level only. And why to fix the issue of the efficiency in as a from maintaining its original size, air filter play a crucial role by filtering dust, bacteria, and any air can extract and sugar fiber. The remaining waste can be turned into air filter sheet to nanofiber size.
In processing, we use nanolayer synchrotic acid replication from nanosite. Air filter sheets we conduct comparative tests using both uncoated cotton and coated cotton, testing in washing and unwashed condition. This aims to verify that link doesn't clog the nanosite fiber pouch, ensuring confidence in the effectiveness when coated with lignin, allowing water and air to pass through. Our experiment observed a stereo microscope demonstrate that lignin doesn't clog the cotton fabric. Nanosite pouch, allowing for easy cleaning and unimpeded airflow when washed.
Thank you and hope you enjoy our presentation.
Okay.
The second layer.
Can I ask the question first?
Yes อาจารย์ดวงเชิญเลยครับ
Okay, so I would like to ask, do you know what is the application for the sugarcane as of now, the current application? Can you hear me?
Yes.
Okay. So do you know currently what did they use the sugarcane as for something? Did you do the literatures?
I know they use the sugarcane for the juice like that.
Oh, that means the sugarcane, right? But
Yeah.
the ash itself, because you want to turn the ash to be something else, right? Do you know what did they use right now? The ash, actually, it's valuable. It has value for it.
It's a fly ash ใช่ไหมฮะ fly ash
Both every part of the sugar, including the leaf of the sugarcane, everything. So that's why I asked, do you know the application right now?
Paper.
Some paper.
Okay,
Can be.
and okay, something else? It's okay if you think of only the paper, it's okay too. Okay. Thank you.
No, she just want to make sure that you understand all the usage of the waste from the sugarcane industry. Yeah. So yes, and that's to evaluate the how your project is viable or able to realize. And then okay, we continue with the questions.
Okay, for me, I will go with a little bit of your experiment. Okay, you mentioned that you're gonna generate create nanopores. I was wondering what technique that you use to determine, okay, the pore size, and if it's possible, can you give me what's the size, and can you give me the estimate what kind of things that you will be able to filter out? Can it filter out the 2.5 what PM 2.5? For example, those kind of things. Yes, yeah, for mass and those kind of thing. What are the application that you can think of? You understand my questions?
What is the use of the filter?
Yes.
We use the electron spinning that can create the nanometer and it can filter like
Nanometer size can filter the nanometer size.
Yeah.
I
The
think
question I think is, where does the filter go? Is it in a machine? Is it in a mask? You can put the filter in a mask. What is the purpose of the filter?
It can filter the 0.25 pm like that, like a mask.
and can use in the air filters in third layer of the air filters.
Like air conditioner or air quality machine like that.
Do you think how long does it last if you happen to use this for the real application? You think what is the replacement? How often you think you have to replace this finding, this innovation?
It can use for 6 months if used around 8 hours per day with stable efficiency.
That's in the technical question. So in your experiment, you extract fiber and you remove the other to get the cellulose fiber, right? And you do for the electrospinning. Is it yes or no?
Yes, we use
Yes, and
electrospinning to do
that's
nanometer
electrospinning for lignin or electrospinning for cellulose.
For
cellulose.
And you also claim for that you extract lignin from sugarcane also, and you coat it on the electrospinning fiber that you extract from cellulose from sugarcane, right?
Yes.
And then you said also you compare with the cotton, right? You coat it on the cotton that is a filter of the air filter, hepta fiber or something, hepta coat, hepta layer of air filter, right? And you compare with you coat with lignin and without lignin, right?
Yes.
So you are both of a component, and you also use this coat on the filter for the other filter hepta also. Because you say electrospinning, so electrospinning you do for the filter, air filter.
Yes.
Coat with lignin, and for this you use like the layer of the air filter.
Yes.
Yes.
So you do for this all, and you compare with that coat and without coating, right?
Yes. Yes.
And you said that this can give more antibacterial property.
More efficiency. More efficiency.
But do you have this taste or not, or you just think that this will be have a antibacterial for after you use your product, right?
Because
Did
we
you
think,
have
in my opinion, if it's smaller, so it can filtering more smaller dust like that.
So smaller lactose meaning fiber, and but that the antibacterial is come from the lignin property. So it's different, right? It's not
Yes.
from. Okay. Thank you.
Okay, that's all. That's all. Thank you very much. The nano air filter team. We move on
Thank
to
you.
other.
May the next team modify constant. Please reintroduce yourself before we open your video.
สวัสดีค่ะ My name is Apishya Gulak. I'm studying at Sathit CMU Demonstration School. Please enjoy my video presentations under the title Bedding Material for Animals from Modified Corn Stems. Beautiful, but it's not fog. After harvesting, some farmers burn cornfield, which causes PM2.5. It has been happening every year. PM2.5 has impacts on various areas: economy, education, social, and most of all, health. If farmers burn corn stem, it causes problems. If they can get money out of it, problems will be solved. According to BCG principle, the corn stem can be modified and used as bedding material for animals. Look at the price. We can earn money from corn stem. Animal urine has ammonia. Modified corn stem can absorb ammonia and water. And I can tell you that the bedding material for animal is expensive. This is how to make it. First, you get corn stem. Cut it. Prepare base trapping solution. Soak the corn stem in the solution. Ready to use. Ammonia solution represents mouse urine. Ammonia taste paper turns green-blue with ammonia vapor. It works! As you can see, this product meets the BCG criteria and solves PM2.5 from cornfield. So let's earn money. Don't burn it.
Hello อาจารย์พิชาติมีคำถาม
The dome first.
โอเคอาจารย์
เปิดเลยนะ
ใช่ใช่
Hello, can you hear me clearly?
Yes, I can hear you.
Yeah, I think you're familiar with the corn stem, right? Do they have any other application for the corn stem in your location, in your area? Did they use for other things?
Yes, it's animal food too.
Okay, and to be the and other thing? It's okay if you can answer one, just okay. So you know that it can feed the animal, right?
Yes, it can feed the animal.
Just my idea. You want to make it as a bedding material, and how big is the bed? How much of the corn stem you need to make one bed?
It's not like a bed. It is a
Yeah, I
piece.
know. Just a piece, place.
Yes, in the cage.
Okay, cage. Yeah. How big? How big of the cage? How big? How many? Like, in reality, you need to have a lot of corn stem, right, to chop down, and you cannot use the scissor to cut it piece by piece, right? So I just want, like, to imagine, like, how big of the cage, or the place, the floor that the animal have to, like, lie down, bedding, and how much of the corn stem you need to have to chop, or cut with your scissor.
It's depend on the cage, but lab animal cage is 1 kilogram for cage.
Oh, you focus on lab animal.
Yes, I focus on
Like
lab animal, and in the future I can do with a pet too.
Like a guinea pig. Yeah, guinea pig. Okay.
Again, please. Sorry.
Guinea pig, right? Guinea pig in the lab, like that.
Yes. Yes.
Okay. อาจารย์เชิญอาจารย์แมทอาจารย์ชาติมี
Okay, for the stem that you are using, before you bring it, to use, what the process that you have to do with it so that you can, use it as a starting materials.
First I get a corn stem and then I peel it off like this, and then I cut it and I dry it. When I dry it, I soak with a solution. Then I can use it. Then it can use it. Yes.
So you basically, if you get the fresh one, right, you can just, bring it, then you just peel, whatever out, and then after that you just use it right away, or you have to dry it first and then you do it further with the process you just mentioned.
When I get a fresh corn, I have to dry it first, and then I cut it. Then I dry it
Okay,
again.
have to dry it. How long you have to dry?
Around 1 days. Depends on the sunlight.
Overnight. Okay.
sun dry.
Okay, sun dry, right? Natural. Okay.
มาแล้วครับ
Okay. You want to add something?
I'm just curious. Will animals try to eat it? Yeah.
No, it shouldn't eat it.
It shouldn't, but they might.
I know. How are you going to tell them not to eat it?
It's the animal has a food of them and they don't need the bedding material.
Any just
Well, it's also is the same concept. I think it's a very clever idea. But can you use the same idea with like rice stem or for a stem of other plants? I mean, why corn? Why not sugar cane or many? And no, they use that, so not sugar cane, but other crops. I'm not a farmer.
Yes, it can use, but we use corn stem because I want to solve PM2.5 because in the 1/3 of Northern has burning corn stem and it's got a PM2.5 the pollution.
Okay. I think it's okay. Okay, thank you very much. So we go on for the next one. Thank you.
The next team, Nano Kokomin. Please briefly introduce yourself before we open your video. Nano Kokomin, are you here? The aloe vera assisted all. Do you hear me? Please briefly introduce yourself. Did you turn on your microphone? Because we cannot hear you.
Vera, aloe vera team, we can't hear you, right? There might be some problem with your connection. I believe you might like we're gonna skip you and come back to you again after the seventh team. After the team number 7, we come back to you again. Okay. You left the Zoom and come back again. Yeah, perhaps the microphone will work. But in the meantime, we're gonna run through, to the next one, and then you will come back to you again after green circuit. Okay. You understand? Please raise your hand if you like. Yes, yes. Okay. You leave and come back again. So we're gonna go for the next one. Okay. See you. We see you. Green gel. Green gel. Okay. Green gel. Okay.
We are going to skip to Green Gel team. Please briefly introduce yourself before we open your video.
Greetings, judges and everyone. I'm Hubert Julia from Patumwan Demonstration School, and today we're presenting a green gel video presentation. Please enjoy our video. Plastic pollution, microplastic accumulation, plastics mismanaging, carbon emission. 2.5 million tons of microplastics will be polluting the ocean environment by 2050. Microplastic cause cancer and blocking blood streams. 400 million tons ends up in incinerating and landfilling. Introducing green gel for eco-friendly alternative plastic waste disposal. It can biodegrade 6 main types of plastic, and it's a perfect mixture of 5 plastic ether with sea kelp medium. Why choose sea kelp? We have rich nutrients, absorbing carbons, and regenerating marine ecosystem. It consists of 50 sea kelp extract, 30 water, and each 10% of glucose and bacteria. Once the gel touches with the plastic, each bacteria will do its job to biodegrade in a strict condition and with each one of chemical process. For the product, we can use it for perfuming, medicines, release it into the ocean, and cooler. For usage method, first you gotta prepare your waste, your plastics separately, and mixing them together with green gel and wait for them to biodegrade. Biodegradation is to degrading something with microorganisms. While PS using oxidating process to degrade, PU use polyurethanolic activities and esterase to degrade. While polypropylene was used as a carbon source, PET was degraded by enzymes and then oxidized. PVC is oxidized into carbonyl and hydroxyl group, while PE shows the record of polysaccharides. MAE is a technique based on the use of the microwave energy to help the transfer from the solutes. In this case, we use it to transfer antioxidants out from the sea kelp gel. Nanobubbles are really small in size, smaller than a single grain of salt. They will be formed using oxygen and injected into the seaweed gel, turning it into the stage of aerogel, which they have really long-lasting. In the near future, we'll be using humidity saver, portable packaging, and using degrading enzymes instead. We'll promote awareness of overflowing plastics and encourage the degrades, which based on usage of green gel. Let's save the planet we're living on together. Thank you.
Okay, very interesting concept. So first of all, I was just gonna back up a little bit more about the initiation of your thoughts and concept. What is your thoughts on why or what is the biggest cost? What is the biggest cost that result the microplastic in the oceans?
So when the microplastics involved in the food cycle, they goes into the planktons first, then they go into bigger aquatic creatures. Then we eat those fishes, those aquamarine types of living things. Then the cycle goes on and on and on, and the microplastics is increased in proportion. So it harms our health and also the animals' health, and lead to extinction and many diseases caused by microplastics.
Yeah, and what is the primary cause to create the microplastics? For example, is that because of the plastic that we use, or either any other cause that you think?
It's about mismanaging plastics. So if we left plastics in a not good condition, or we let them degrade by their own, so they just degrade into very little microplastics. This is the main cause of it. Yeah.
Okay. But you think how long does it take to make such a plastic to become microplastic?
It depends on the type of each polymers, but for example,
PP.
PP, it takes around 500 years if
Okay,
if
so that
foam.
means it's not the biggest cost to create the microplastic, right? Because it takes 500 years to produce
Yes.
microplastic, right?
While
Probably there
the
is other cost to create those, right? Okay, just try to hint you something about this. Okay.
So your green gel is composed enzyme that can degrade the microplastic, right? So how about component in green gel, the mainly component?
I would say the bacteria provides those enzymes, not the enzymes on its own. The bacteria provides enzyme, yes, to degrade.
Then you choose, for example, if you want to degrade polyurethane or polypropylene, so it's the same component in this green gel, or you separate? You mean that if polyurethane or PP, so you need the green gel, green gel number one. For example, if you want to degrade PET, you need green gel number two, or all together, mixed together in the one green gel.
All together mixed in one green gel, because separating each types of plastics may be costing more to, just separate each things and just make it harder. So we just combine 5 main bacteria into one gel to make it easier.
Your product is relying a lot on kelp. Is that correct? Kelp is important.
Yes, it's
How available is kelp? Is kelp one of those aspects of ocean that is actually decreasing as climate change and and the environment is having problems, is kelp available? I don't know. I'm worried about, is kelp going to be available, readily available, easy to get and easy to use?
Yes, in some point, the sea kelp is running out in some specific area of our world, but in some areas there is a thing called sea kelp choking of the shores. Sea kelp is flooding the shores and it's destroying the natural living things that based on those area, and it destroys all. So it's harmful to some environment. We tend to help them collect them all and use it into a more useful usage.
Okay. Just a quick question. After you use these 5 bacteria, your green gel, what's next? What's next from you get what you want? What's next?
The next level is to, it's the bacteria itself, because the bacteria requires many conditions based on humidity and temperature. If we just extract the exact enzymes that biodegrades that specific polymers out of the bacteria, if we have that ability to do that, it will be more easier to conduct and to transporting into all over the world. It will be more easier to maintain the conditions.
Okay, so you want to reuse your bacteria for more and more and produce the bacteria more and more, right?
Yes.
Yeah.
Thank you very much. So
thank you.
Yes.
May the next team, Green Circuit Tiger Ranger. Please briefly introduce yourself before you open your video.
Okay. Hello everyone. We are from Princess Julapur Science High School, Pathum Thani. Today we would like to present our innovative idea, Listen It. Hello, we are Green Circuit Tiger Ranger. Currently, our world is filled with electronic devices that become electronic waste when they reach the end of their lifespan. In 2016, UNEP identified that printed circuit boards were found about 17 million tons of e-waste, which only 3 million tons are eliminated. These printed circuit boards make a significant carbon footprint and makes human harmful. It releases harmful chemicals and being hard to decompose. So it makes soil and water pollution due to its components like plastics, toxic, coating substance, and halogen. In 2017, EPPO identified that 1.8 million air conditioners were installed in Thailand, and it tends to increase, which means it will have more e-waste in the future.
According with BCG concept, to solve this issue, our team has an idea of creating circuit board for air conditioner from bioagricultural waste, which is mycelium and rustol, that is strong and highly heat resistant. First, we mix between mycelium and rustol in various ratio R1:1, 1:2, 1:3, and 1:4. Then take it to be formed with hydraulic heat pressure machine. Next, we take it to heat and degradability test to determine the proportion. First, we take the degradability test with 5 factors: artisan soil and sand, 1 week, and 3 samples of water pH 7, acid pH, and base pH 10 for 2 days. And heat resistant test with temperature of 100 degrees Celsius for 6 hours.
In conclusion, we found that 1:1 is the best proportion for making printed circuit board due to its properties that it is the strongest, slightly decomposed, and highly heat resistant, but doesn't toxic. In summary, the concept of this idea all of BCG's concept. It won't be toxic. It's released to environment. It will reduce accumulating of e-waste and carbon footprint emissions. This innovation will maximize the benefit of rice, flour, and fungi, which is based in agriculture.
Furthermore, this innovation is low cost to produce. In the future, we can develop this to use with other devices. This innovative idea can divert the Thai economy to in tandem with social development and environmental conservation in a valuable and sustainable manner. Lastly, we persuade every air conditioner companies and auto electronic companies of every country to use this innovation to driving economy and solve the problem. Thank you for listening. If you want to know more about our idea, let us explain you in the competition day.
Just the green one.
Yes.
The green.
Yes. I think. Thank you for the presentation. Yeah.
We have the green.
We have some like something need to be clarified a little bit, right?
Okay.
Which is there will be more question, but I will ask first and then Matt. Yeah.
No,
Okay.
no, go ahead.
Yeah, okay.
I don't know enough to ask questions.
Okay.
So go.
Okay. I wonder like in how long it gonna be last your product, your idea, since you said it's biodegradable, right?
Not the container.
You mean its lifespan, right?
Yes. Lifespan. You can say lifespan, or it can be.
Okay.
I hope your computer will not be rotten, like when you using it.
Actually, we target to develop this innovation to be used around 20,000 hours, like equivalent to the other circuit board. But the duration is too short to do, so we still can estimate its lifespan. But if we have more time, we believe that we could done it. Yes.
So I want to ask the next question. So how high the temperature can this board take?
Okay, it can from our estimate it can be into 200 degrees Celsius. It can be used in 2000 degrees Celsius from mycelium's properties.
2000 again?
Yes.
2000?
200, sorry. Sorry.
I was like
200.
2000.
Yes. Sorry.
So again, one more time. 2000 or 200?
200.
Okay, 200. So do you think your product is like well insulated? Is the good insulator? Do you think that should what is the property that make you sure that this will be the good insulator? Because I think you make the insulator part on the circuit board.
From our experiment, we found that it can be used in 100 degrees Celsius for 6 hours and it didn't change at all. Yes.
Okay, you
From
have
the
the
property of
preliminary
mycelium.
for 6 hours, right? And 100.
Research with me.
6 hours and 100. Okay.
Okay, it's very interesting, but the only thing that I would like to know is that when you make the print circuit board, you have to make sure that you have to put some metal parts on top of it as well, right? How do you sure that, how are you sure that this one will be able to make a complete circuit, because you need to put diodes or whatever other parts of electrical parts on the top as well. So you think it's gonna work with your innovation?
Sure.
How to convince me?
For our innovative idea, we want to produce the substrate, and then we have to coating with bio soldier mask to put the other electronic components there. Yes.
Any plan that you wanna add on that?
Yes, sure. In the future.
In the future, okay.
Okay. So you so continue with Professor Abhishek said I was do you know currently how did they print that metal part, the metal line on the circuit board, on the PCB? Do you know what did they do?
We use copper. They use copper, but we use uh, carbon ink to print on the sub this substrate. We use a carbon ink to print on the substrate.
Actually have to be via, but it's also can use
Yeah. So it's a metal part, right?
metal.
Metal part.
They have to cut down a little bit.
Yeah. That's why I wanted to, because I would love to see it in a commercial, but let's say that.
Come and make company with us.
Yeah, I just want to make sure that you know the current technology, right?
One last question, Kat. Time out. Okay. So if this technology is not work for the print circuit board, what is other application you think of? Just quick answer.
For this innovative idea, right?
Yeah. Other application instead of PCB. Okay, never mind. Just come and study with us at Kasetsart.
In the future, we plan to expand the scope of the project by optimize its properties of this printed circuit screen and adapt it to be used in another devices. So this solution will definitely be good for commercial.
Okay. Thank you very much. Yes.
Thank you.
We appreciate your answer. Okay. So
Next,
next we go back to aloe vera. Okay, first. Okay. Are you with us now?
Yes.
Yes. Okay. We can hear you. But very soft. Team Dev. Okay, sorry. Aloe vera.
Yes.
Yes.
Can you hear me?
Okay. Yes. Yes.
We are
Okay.
sorry for any inconvenience that may have been caused. Dear KU BCC Ideation, Dear KU BCC Ideation Challenge 2023 Committee, dear professors, scientists, and friends, I am Võ Nguyễn Cát Tường. I am Võ Nguyễn Hải Châu. I am Thiên Bình. I am Lê Nhật Cảnh Huyền.
thank you. Please wait for a moment while we are opening your video.
Okay. Okay, the team will start asking questions. Since
Can you explain your product and its use? Who is it for? What is your product?
I would like to share my presentation. Is that okay?
I can hear you. Yes, please answer the questions. Okay.
Did you hear?
I can hear only one person, but I cannot hear the others.
I would like to share my presentation.
Okay.
Is that okay?
Yes.
Yes, we saw your presentations, and now it's a questions already from Jan Matt, from Dr. Matt. Okay. Please answer please questions again.
Can you hear us? You can hear?
Yes.
Okay. The question is, please explain your product. What is it? Who uses it?
We product is product for females.
For females. I mean for females, right? Can you explain a little bit more, because your presentation didn't tell anything, so you can provide a little bit more details what to do with it?
Yes.
Okay, yeah. I can imagine, but I just want to.
Yeah. เขาก็จะตอบไม่ได้ใช่น่ากลัวมากคุณไม่ต้องผ่านออย
Our presentation includes four main parts.
ให้ผู้หญิงถามดีกว่าไหม
Part 1 is introduction, part 2 is materials and methods, part 3 is result, and part 4 is conclusion.
I'm sorry, we can't let you use the presentation. It's the Q&A. There's no further presentation. Yes, you have to answer our question only, right? I hope you understand this. This is the rule of the competition. Okay. So okay, Achan. Okay. We will give more questions for you. Okay.
How to use your product?
Can you repeat the question?
How can we use your product? ได้เลยกูโคภาษาเวียดนามอะไรอย่างนี้
English is good.
The language is good, but I think
about the technology. You can hear us.
We use essential oil and
Yes.
curcumin gel combined with aloe vera.
Yes. How?
And Catazan for treatment of vaginitis in females.
Where to apply it?
อุ้ยอันนี้คือเข้าไปที่โอเค what is you use it for to make the to make the skin better or to kill the bacteria, kill the virus?
Use some material.
Kill the bacteria, right?
Yes.
So which part of the body? Yeah. Yeah. So there's a good bacteria and bad bacteria. How your product know which one is good, which one is bad?
Bacterial only clinical test had not conducted.
Oh, the bacteria. Okay, how your gel know it's good bacteria or bad bacteria?
Bad bacteria.
Bad bacteria. Okay, how the gel know? How do you know which one is good, which one is bad?
I think um,
It's okay. You can do more research because you use for the internal use. You have to be careful. That's why I asked you question. Okay?
Okay. So this one quite intimate to the ladies, right? So we can't give much of information of the question, but the one thing it is a comment, right? Because the product is internal use, so it will have a lot of like test risk assessment, like the FDA, Food and Drugs things, allergy test, and many things, uh, and how I hope you understand the process that come into the bring an idea to the market. Right? Okay. By the way, the time is up. So we appreciate your presentations, and we will move on to the other team. Thank you.
Thank you.
Okay. But okay. And before we ไม่เอามานะครับ Okay, we have the other team. Yes, yeah, not yet. We have other teams. I have to say that the team sent the email to us, and it was in the junk mail. The Pomelo biofilm. Are you here with us?
yes.
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 Okay.
Yes.
One more team. Oh, there's one more team.
One more team. Yes.
Okay.
Biofilm. Okay. Biofilm.
Yes.
Okay. Please introduce yourself. Okay. You have a chance. So yeah, introduce yourself and play. We will play the video follow. Okay. Please go on.
Okay, good morning everyone and Georges. And we come from Pomelo by Open team from Galayanisi Tamara School.
Sorry for our email problem and thank you for your gift and opportunity.
We hope everyone enjoy with our presentation. Thank you.
Thank you. Please wait for a moment.
Hello everyone. I'm Second. We are Pomelo Biology from Galayani Samaras.
When discussing the economic plan of southern Thailand, many people think of oil palm or rubber tree. However, there is another significant agricultural plant known in the region, the pomelo in the Pak Panang district. The famous Taptim Siam pomelo are grown and have been exported to various foreign countries. The process of peeling the fruit to sell the pulp generates a large amount of waste from the peel. The cost of the depot of this waste in landfill or by burning will lead to soil and air pollution.
To address this issue, another study conducted by Mr. Vachara Viangkel from Srinakarin Virod University focuses on pectin extraction from lime peel using stem treatment. This study has shown that pectin in pomelo peel can treat wastewater and make film flexible and biodegradable. Thus, we are exploring ways to add value to pomelo peel.
In recent times, the participation in the Loi Krathong festival has diminished. However, Loi Krathong is still a significant tradition and an integral part of Thailand's beautiful culture, attracting both Thais and foreigners and boosting tourism. The tradition, however, negatively impacts water sources. A typical krathong made of banana trees, banana leaves, flowers, incense sticks, and candles contribute to water pollution. Krathongs made from bread introduce bacteria and create waste, further polluting the water.
From our research,
We have developed a biofilm made from pomelo peels that dissolve in water and includes chitosan. This idea is supported by research on biodegradable packaging development using shrimp shells, chitin and chitosan by Mr. Somkiat Ditkaew from Prince of Songkla University. Chitosan extractable from shrimp shells is abundant as Nakhon Si Thammarat is a leading exporter of gula shrimp. When formed into a gratong, our product not only dissolves in water but also contains chitosan, which helps eliminate bacteria and reduce wastewater.
We believe our biofilm from pomelo peels can significantly reduce waste without causing environmental harm and encouraging people to return to tradition of Loi Krathong.
Okay, nice. So you still didn't have the full katong yet, right?
Yes.
Okay.
Uh, my quick question. What else you can apply your film, your product to other application? Can you give me some idea? Uh, ยังไม่ได้ตอบใช่ไหม
A bio packaging, the food packaging.
Okay, food packaging. So, okay, do you think your biofilm can benefit to what kind of packaging? I mean, food packaging. What kind of food that you think is will be benefit?
Or from the industrial process.
It's easy to biodegradable and it can dissolve in water and it's not to be pollution.
Okay. So you want to use your film to wrap which food? What kind of food do you to use this?
Or a noodle or a coffee.
Yes.
Yes.
Coffee. Okay.
Hot coffee. You can use it for. I have a question. Well, two. One, hot coffee, and the other is it edible? I mean, can you eat it?
It's a coffee powder.
Oh, okay. Coffee powder. Okay.
Okay.
Seasoning in instant soup.
ก๋วยเตี๋ยว seasoning for ก๋วยเตี๋ยว no? Yeah.
Sorry, I can't hear the question.
It's okay. It's okay. อาจารย์เพิ่มเติม
So your technique to do for the biofilm is just a solution casing. But if you want to apply for the industrial, so which technique that you can do? Because just casing maybe it take time and also you need a surface to do. But if in the future you do for the food packaging, what is your idea for to apply for the technique to prepare biofilm?
Excuse me, can you repeat the question, please?
You say that your technique to do biofilm is just for solution casing, right? So solution casing you need a surface to do. But in the future, if you want to do for the food packaging, what the technique to prepare your film?
I hadn't thought about that. Yeah.
Okay. So yes, you can answer.
We use pomelo pills from can can come
From our
another
we use the pomelo peel from the pomelo part to sell and have the waste of the pomelo peel, right? And we use
Yes.
this pomelo peel
to make a biofilm
yes
to make a product to sell them.
Okay. So have you ever tried the theory? This theory, your steps. Have you ever tried?
no
No.
Right? Okay, it's okay too. It's okay. Yeah, this is an idea. But one last question for me is like, if you want to use the pomelo peel, that means every pomelo have to be peeled at Nakhon Si Thammarat, right? But when you sell the pomelo, you sell it with the chill, you know. So how can I think you may have to find the process to sell the pomelo without the shell too. Okay.
Keep the shell.
You understand what I mean? So it's like you have to have the enough supply to do the biofilm. Okay. Do you understand what I try to say?
Yeah.
How you can find the peel?
From big markets or from, I guess.
How can you find a lot of peel? Do you have any plan?
in the Pak Panang is อะไรนั่นแหละ
It's many
many pomelo peels in the Pak Panang and is always have all the years
Okay. โอเคขอบคุณเลยก็ได้หมดเวลา
Okay, time is up now. Okay, thank you very much for the biofilm, and I'm glad for your like that you can join the events, and I'm sorry again for the mistake that we made, but anyway, you have done a good job for presenting to us, and that's a wrap for the morning sessions, and I hope you enjoy as we do enjoy the presentations, and we come back in about an hour, 12:30 for the university sessions, and I hope you continue and stay tuned with us, and we would pass it to our MC. Thank you very much again, all the team.
Thank you, all the contestants. We will be ending the current session here. Please be patient as our esteemed judges are considering and finalizing the scores. Please stay tuned and make sure you don't miss any amazing moments and come back again at 12:30 in KU BCG Ideation Challenge 2023 for non-food category. สวัสดีค่ะ